Hi, Assalamualaikum. My name is Nurul Izzah binti Abdul Basir and my metric number is 297992. The first question, A1, is given the above model, describe the relationship between any two goods, whether they are substitute, complement, etc. and justify your answer. So I will explain the answer for question 1. The first two goods that we can describe is good 1 and good 2. The first equation 1 and equation 2 is constitute for the good 1, and while equation 3 and equations 4 will constitute for the good 2. In demand equation for good 1, which is equation 1, we have negative coefficient, which is negative alpha 1 for the price for good 1. In supply equation for good 2, equation 4, we have positive coefficient, which is delta 2 for the price for good 2. This is consistent with the law of demand, which is an increase in the price of good 1 will decrease the quantity demanded, while an increase in price for good 2 will increase the quantity demanded for good 1. So we can conclude that good 1 is an input production for good 2. So good 1 and good 2 are substitute. The second one, we can describe their relationship is between good 1 and good 3. The equation 1 and equation 2 will constitute the market of good 1, while for equation 5 and equation 6 will constitute the market for good 3. In demand equation for good 1, equation 1, we have positive coefficient, which is alpha 3 for the price for good 1. In supply equation for good 3, which is equation 6, we have positive coefficient, which is psi 3 for the price for good 3. This is consistent with the law of demand. When the price of good 3 increase, the quantity demanded of good 1 increase, while an increase in good 3, the quantity supply for good 3 also increase. So we can conclude that good 1 is an input production for good 3. So good 1 and good 3 are complement. Next, we continue for the question A2. Use equilibrium condition QDI equal to QSI for I, 1, 2, 3. Derive the system of the simultaneous equation in the price variable and transform them into the metric form. So the answer for A2 is, the first step we can do is we can arrange the equation good 1, good 2 and good 3 in equilibrium condition, which is QD equal to QS. The equation for good 1 is QD1 equal to QS1. We can arrange equal to alpha 0 minus alpha 1 P1 plus alpha 3 P3 equal to negative beta 0 positive beta 1 P1 minus B2 P2. After that, we do for good 2. QD2 equal to QS2, which is gamma 0 minus gamma 2 P2 equal to negative delta 0 plus delta 2 P2. We also do the same method for the good 3. Good 3 is QD3 equal to QS3. Phi 0 plus phi 1 P1 minus phi 3 P3 equal to negative psi 0 negative psi 2 P2 plus psi 3 P3. Second step, we will rearrange back the question that we will get at the step 1. So for the good 1, after we rearrange, we will get alpha 0 plus beta 0 equal to alpha 1 P1 plus beta 1 P1 minus beta 2 P2 minus alpha 3 P3. Next, the good 2, we will get gamma 0 plus delta 0 equal to gamma 2 P2 plus delta 2 P2. For good 3, we will get phi 0 plus psi 0 equal to negative phi 1 P1 minus psi 2 P2 plus phi 3 P3 plus psi 3 P3. The last step is we can express the equation into the metric form. We will use the formula A times P equal to B. So, the metric form is alpha plus beta, negative alpha, 0, negative gamma, negative beta, 0, negative phi, negative psi, phi plus psi times P1, P2, P3 equal to alpha 0 plus beta 0, gamma 0 plus delta 0, phi 0 plus psi 0. That's all for me. Thank you.
My name is Aina Ilani Binti Muhammad Adnan with metric number 291372. So for question B1, derive a system of three simultaneous equations in the price variables. To achieve the equilibrium, we need to consider that quantity demanded and quantity supplied is equal. So for good ones, we can get the 60 minus P1 plus 2P3 equal to negative 40 plus 2P1 minus 5P2, and we get the final answer is negative 3P1 plus 5P2 plus 2P3 equal to negative 100. So for good 2, we need to put QD2 equal to QS2, and we get the equation is 80 minus 2P2 equal to negative 70 plus 2P2, and we get the final answer is 4P2 equal to 150. For good 3, we will put QD3 equal to QST, and we get the equation is 70 plus 2P1 minus 2P3 equal to negative 50 minus 3P2 plus 2P3, and we get the final answer is 2P1 plus 3P2 minus 4P3 equal to negative 120. To answer the question that asked to put into metric forms, we need the three simultaneous equation that we get, which is for good 1, negative 3P1 plus 5P2 plus 2P3 equal to negative 100. For good 2, 4P2 equal to 150, and for good 3, 2P1 plus 3P2 minus 4P3 equal to negative 120. We need to put them into the A, X equal to D, which we take out the numbers from P1, P2 and P3, put it in A, and for X is P1, P2 and P3, and for D is the answers for the equation. So for question B2, we need to use the Cramer rules to find the equilibrium price. For the first step, we need to find determinant A, which the numbers we get from the metric form in the previous question. So we will get negative 3 in bracket 4 times negative 4 minus 0 times 3 minus 5 in bracket 0 times 4 minus 0 times 2 and plus 2 in bracket 0 times 3 minus 4 times 2. And the final answer for determinant A is 32. For the second step, we need to find the determinant A1, determinant A2 and also A3, which obtained by replacing the element in column 1, 2 and 3 of matrix A respectively by the element in the vector D from the previous answer. For determinant A1, we need to replace the number from the column 1 with the number that we get, which is negative 100, 150 and also negative 120. For determinant A2, we need to replace the numbers in column 2 with the same number, and for the determinant A3, we need to replace the numbers in the column 3. So we get the final answer for A1 is 6,460, determinant A2 1,200 and determinant A3 5,090. For the final step, which we will get the final answer for P1, P2 and P3, we need to divide the determinant A1, A2 and A3 with determinant A. So for P1, determinant A1 divided by determinant A, which will get the answer 6,460 divided by 32, which is P1 is equal to 201.88. For P2, determinant A2 divided by determinant A, 1,200 divided by 32, the answer will get 37.5, and for the P3, determinant A3 divided by determinant A, 5090 divided by 32, with the final answer for P3 is 159.06.
Good morning everyone, my name is Tan Jun Yu. I will solve the question B3 using the inversion method solve for the equilibrium price. So we need to let the QD1 equal to QS1, QD2 equal to QS2, and QD3 equal to QS3. After our solution, we will get 3P1 minus 5P2 minus 2P3 equal to 100 as our equation 1, and 4P2 equal to 150 as our equation 2, and negative 2P1 minus 3P2 plus 4P3 equal to 120 as our equation 3. After we get the three same simultaneous equation in P1, P2 and P3, and we can write the equation in metric form, which is A equal to 3, negative 5, negative 2, 0, 4, 0, negative 2, negative 3, and 4. And X equal to P1, P2, P3, and B equal to 100, 150, 120. Inverse metric A equal to 1 over determinant A multiple adjoint A. To find the determinant A equal to 3 bracket 4 multiple 4 equal to 16 minus 0 multiple negative 3 plus 5 bracket 0 multiple 4 equal to 0, then 0 multiple negative 2 equal to 0, then 0 minus 0 bracket minus 2 bracket 0 multiple negative 3 which is 0, and 4 multiple negative 2 which is 8. Then we will get 48 plus 0 minus 16 which is 32. Since there are 9 elements in the matrix A, so it will have 9 cofactors in matrix A. To calculate the adjoint A, A11 equal to 4, 0, negative 3, 4, and A12 equal to 0, 0, negative 2, 4, and A13 equal to 0, 4, negative 2, negative 3. After the solution, we will get the A11 equal to 16, A12 equal to 0, A13 equal to 8, A21 equal to 26, A22 equal to 8, A23 equal to 19, A31 equal to 8, A32 equal to 0, and A33 equal to 12. So we need to switch 0 with 26, and 8 with 8, and 19 with 0. Then we will get the adjoint A. So inverse A equal to 1 over 32, and multiply the adjoint A, which is 16, 26, 8, 0, 8, 0, 8, 19, 12. X equal to inverse A multiple B, which is 1 over 32, then 16 multiple 100 plus 26 multiple 150 plus 8 multiple 120. We will get 1 over 32 multiple 6460 1200 5090. Then we will get P1 equal to 201.875, P2 equal to 37.5, P3 equal to 159.0625.